In this video, we will cover placing MEP connectors and adjusting connector properties. In this project, several components have been placed. When you select a component, you can see various options on the contextual ribbon in the Create Systems panel. These options are indicative of the connectors that have been placed on the component and control the systems that they can be added to. To take a closer look at this, I'll select the water source heat pump and then click Edit Family in the contextual ribbon. As you can see, there are several connectors that have been placed on this equipment family. To place a connector, you can use one of the tools on the Create ribbon in the Connectors panel. These tools will control the discipline of the connector, which then controls the type of system that the component can be added to. I'll click Duct Connector. When placing a connector, you can use one of the placement options. You can select Place on Face or Place on Work Plane. Most of the time, you will want to use Place on Face. This option gives you the most control over where that connector is placed. I'll click Modify and we'll take a closer look at this. As you can see, the pipe connectors are placed on cylinders, and then the duct connectors are also placed on geometry. And so a good practice is to create geometry that is obviously constrained to the overall geometry of the equipment, and then place the connector on that geometry. And you can use the same parameters to control the size. That's why the pipe connectors match the size of the cylinders and the duct connectors match the size of the geometry that they are placed on. You'll also notice that there are arrows pointing out on all of these connectors. And you'll also notice that there is a flow direction parameter in the Properties palette. Now this is something that a lot of people will get confused about, as they think that the arrow controls the flow direction, and that's not really the case here. And so what the arrow means is that that is the direction that the associated duct or pipe is coming from and will be connected to. In other words, it will control the side that the duct or pipe will connect to. So if I use the flip arrow here on this duct connector, now that duct connector is pointing to the inside of the equipment. And so some people think, well, if that's the way the air is flowing, then that's how I need to set the connector, and that's not the case. You will want it to be pointing toward the direction that the duct or pipe is coming from and will be connected to. Then you can control the flow direction, and that can either be in or out or bidirectional. So in this case, this is the supply air connector, so the supply air duct connector on this equipment, and air will be flowing out of that connector. And then if I select the return air connector, you can see that the flow direction is in, and so it's coming into this connector. So even though the arrow is pointing out, the air will be coming into this connector and then obviously into the equipment. So that's something you need to be paying attention to when it comes to the flow direction. Another important thing to be aware of is the system classification. This will determine the system type that the connector can be added to. And so as you can see here, there's supply air, return air, exhaust air. Those match the system classifications in Revit. And then similarly for pipe connectors, you can see the system classifications that are available there, and that those will match the system types, the system classifications of the system types in Revit. So you'll also see a couple more there. You may see an other, and then there's a global and a fitting. Now, when fitting obviously can be used for fittings, and then global can be used for accessories, or even sometimes you may want to use a global system classification on some types of equipment or other fixtures. But the important thing to note here is that the system classification of the connector must match the system classification of the system type that you are creating in your project. A couple other important things to pay attention to. The flow configuration. That is something that you're going to want to pay attention to. Now, in this equipment family, the flow configuration is set to calculated. And so what's going to happen here is that any air terminals that are downstream of this connector, the flow will be totaled, and that will be the flow for this duct connector. When it is set to preset, then it's simply a user preset value. And then if I select system, you'll notice that this flow factor becomes available. And when the flow configuration is set to system, then a percentage of the system airflow is allocated to each of the downstream components. And that percentage is controlled by the flow factor. So typically equipment, you'll have the flow configuration set to calculated, and then for things like air terminals, you'll have it set to preset. So I'll leave this one set to calculated. And then you can specify a loss method for the connector. If you select coefficient, then the loss coefficient will become available. If you select a specific loss, then you'll be able to define a specific pressure drop. I'll leave it set to not defined. And then the flow, you'll typically want to associate that with some type of parameter. In this case, an airflow parameter has been created, and the flow for this duct connector has been associated to that parameter. As far as pipe connectors, very similar. You want to set the flow configuration, flow direction, system classification. Those are all extremely important. And then once again, you'll want to associate the flow parameters so that you can control the flow in the project, and you'll have specific parameters that you'll be able to do that. And you can also associate some of the other parameters here, such as the pressure drop. And then you can also enter a connector description. That's always useful when adding certain components to systems. Okay, last thing we'll touch on here is you'll notice that there's a pipe connector that has crosshairs there, and then there's also a duct connector. This represents the primary connector. And really the primary connector is something you'll want to focus on when you're creating some type of fitting that uses a global setting or using a global fitting. You'll want to pay attention to those. And also when you select a connector, if you notice these dashed lines, that represents connectors that have been linked. And so you can link connectors there, and so that's typically when you're dealing with supply and return on the same piece of equipment. So once again, connectors are extremely important. You'll want to make sure that you have those defined correctly so that you can get your system set up correctly. In this video, we will cover differentiating between system and component families and editing system and component families. In this project, several elements have been placed. It's important that you understand the difference between system and component families. Component families are also referred to as loadable families. They are defined in the family editor and saved as a .rfa family file. They are then loaded into a project. System families are defined within the Revit project. When you select an element, if you see Edit Family in the contextual ribbon, then you know that that component is a loadable family or a component family. If you select a component and that does not appear, then it's most likely a system family. On the MEP side, ductwork, piping, conduit, cable trays, The actual duct, pipe, conduit, and cable tray, those are system families, whereas the fittings and accessories are loadable families. So those are defined right within the project. In other words, when you select a duct or a pipe, you can then click Edit Type, and you can use the type properties to define that family. In other words, you're not going to open it in the family editor. It's controlled right here in the Type Properties dialog. I'll click Cancel, and then I'll select one of the fittings. When I do, you can see that Edit Family appears, indicating that it is a loadable family. Most of the other components that I have here in this project are also loadable components. I'll select an air terminal and then click Edit Family. When I do, the family opens in the Family Editor, and you can see that the tools are much different than in the project. Here you can create geometry, you can create connectors, you can add parameters, and all of that will control how that family behaves in the project. I'll switch back into the project, and now we'll take a look at editing the families, specifically the loadable family components, and taking a look at some of the things you need to be aware of. When I select this Supply Air Terminal and expand the type selector, you can see that there's one type, a 24 by 24 face 12 by 12 connection. I can click Edit Type to open the type properties, and I can modify these type properties, and I can even create new types right here in the family. So even though it's a loadable family component and defined in the family editor, I can still create a new type here in the project. For example, I'll click Duplicate, and then let's create a 24 by 24 face with a 10 by 10 connection, and I'll click OK. Now I'll set the duct width and the duct height to 10 inches, and then I will click OK. Now when I expand the type selector, I have two types. I have the original one and then the new one that I created. I can click Edit Type and I can switch between those types as well. And the difference is simply two of the parameters. And so once again, your type parameters are what's going to control the family type. I'll click OK, and then I will switch back to the family in the family editor. And now when I click Family Types and I expand the type name, you can see that there's only one type. So this is where it can get a little confusing, because we modified the family in the project, but it didn't update the family file. And the reason is when you load a family into a project, you can still modify it inside the Revit project, but it's not going to affect that external family file unless you open it and then you can save it externally as well. So at this point, we really have two different versions of the family. We have what's here in the Revit project, and then we have what we originally opened before we created that new type. But if I close this and then I open it in the family editor, and I go back to the family types dialog, you can see that we have two types now. And I can even create a new type, and we'll create one that's a 24 by 24 face, and let's do an 8 by 8 connection. And then click OK. And we'll set the duct width and height to 8 inches. And then click OK. Now I can load it into the project, and I get this dialog. The family already exists dialog is important. You need to be aware of what these controls do. Overwrite the existing version will overwrite the existing version. It'll add in the new type. It'll add in new parameters that you added. Whereas the second option, overwrite the existing version and its parameter values, will do the same thing. It'll load it in. It will add any new types or any new parameters that were added, but then it will also override parameter values that have been modified in the family editor. With that said, it's not going to override every single one. There are some instance parameters that control geometry that it may not override, but you need to be aware that there can be type parameters that can be overridden in the project. For this example, I'll select overwrite the existing version, and then when I select the family and expand the type selector, you can see that there are now 3 types. So I know we're kind of going in circles here, but the important thing to understand is that you can create new component family types in the project, and they do not affect the external family file unless you open it after those new types have been created. If you want to adjust the geometry or the parameters that are available, you will need to do that here in the family editor. So, just to summarize, the important thing to understand is that system families are defined within the Revit project, whereas loadable families are defined in the family editor. In this video, we will cover recognizing family creation best practices and creating parametric geometry and connectors. To create a new family, click the File tab and then select New Family. In the New Family, select Template File dialog. You can select the template you want to use to begin your family. For this example, select Mechanical Equipment.rft and click Open. There are some family creation best practices that you should follow to help you create a parametric family. That begins with creating the framework of your family using reference planes, and then adding dimensions to control the reference planes. After that, you can label those dimensions with parameters, and then create geometry and constrain it to the reference planes. Let's take a look at how this works. To begin, on the Create ribbon, in the Datum panel, click Reference Plane. We'll create a left and right reference plane as well as a front and back reference plane. After that, I'll click Modify to end the command, and then when you select a reference plane, you can name it. So I'll name this one Front, and then you can control the Is reference, which will determine the priority that Revit will assign to it in the project environment. So I'll select Front and then Back. So in other words, when you're dimensioning to the component in the project, Revit will look at this Is reference value, and that will help determine the priority level that it finds. And then the name will help it'll give you a tooltip in the project environment so that you can see what you are dimensioning to. Lastly, we'll set this to right and name it Right. And then we'll switch to the front elevation view and create 2 more reference planes. One for the top of our equipment, and then we'll create another one for the top of the connection. And I'll go ahead and name those as well. And so if there's not a specific option, you can always select strong reference. All the other options will use a strong reference except for a weak reference, and then you can choose for it to not even be a reference if you don't want Revit to find it. And that is in the project when you're dimensioning to it. Okay, back in our reference level view, now that we have reference planes created, we need to add dimensions. So on the Annotate ribbon in the Dimension panel, I'll click Aligned. And what we want to do here is create a string and create an equality constraint, and then we'll create an overall dimension. And so what this will do is it will always keep the center at the center, and the left and right or front and back an equidistance away from the center reference plane. Next, I'm going to click Family Types, And this button is available on the Modify ribbon as well as the Create ribbon. And in this dialog, we can create parameters and then also family types. So I'll select New, and we'll create a parameter for the length. We'll create one for the width. And then while we're at it, let's create one for the height, the connection height, and then the connection diameter. And I'll click OK. And we will essentially create a cube, and we'll set that to 1 inch, and then our connection diameter, we'll set it to 6 inches for now. And then click OK. Now, when I select a dimension, you'll notice on the contextual ribbon there is a label dimension panel with a label drop-down. And when I expand that, I can select any of the dimensions that will, any of the parameters that will work for this dimension. So in this case, these are length parameters, and this is a length dimension. So I can select either any of these. So I'll select length, and then for this one, we'll set it to width. And then we'll add dimensions in our front view as well. And lastly, we'll label these dimensions. This is the overall height, and this is our connection height. Now, in the reference level view, let's add our geometry. So now we have parameters that are driving our reference plane, so now we have a good framework, and so now we can add the geometry. So on the Create ribbon, in the Form panel, click Extrusion, and then in the Draw Gallery, select Rectangle, and I will click this corner intersection of the reference planes, and then I will click the padlock icons to lock my sketch lines to the reference planes. And so this controls the 2D sketch, if you will, and then I'll click Finish Edit Mode. And with the extrusion still selected, I'll switch to the front view. And now I have controls that I can use to drag the top and the bottom. I'm going to drag the top to my top reference plane, and when I snap to it, I have a padlock icon. I can lock it. And the bottom is where I want it to be, but it's not constrained, and so I'll actually drag up and then back down, and so that I can lock it there to the bottom. So at this point, we have a cube for our mechanical equipment. And back on the reference level, let's create a cylinder for our connector. So on the Create ribbon, I'll click Extrusion again, and then click Circle. And I'll create a circle and then click Modify. Then on the Annotate ribbon, I'm going to activate the Diameter Dimension tool. And then we will label this dimension with the connection diameter. And then I'll click Finish Edit Mode. Back in the 3D view, you can see that our connector is not there, and the reason is because it's basically at the bottom. And so when I select it, I can drag the top to the connection top, lock it, and then we'll drag the bottom to the top of the equipment. And now you can see it there. Next, on the Create ribbon, in the Connectors panel, I'll select Duct Connector, and with Place on Face selected, I'll select the face of the cylinder and click Modify. And then I'll select the connector and change the shape to round, and I will associate the diameter of the connector to the connection diameter parameter that we created. And now we have the beginning of a mechanical equipment family. The last thing we can do is flex it, or the last thing in this example, and we'll adjust these values and click Apply and make sure that everything is updating correctly. And as long as it is, then that means all of your constraints should be working properly. So obviously there's some more work to do with this family, but as far as best practices go, you want to create your reference planes, add dimensions, label those dimensions, and then constrain the geometry to those reference planes, and then flex it and make sure everything's working properly. In this video, we will cover determining the family category and determining the part type. When creating families, it's critical that they are assigned the correct category and part type right from the beginning. First off, the category controls some of the default parameters that will be available and also controls the visibility and graphic display of the components in the project. And the part type will determine the behavior of that component. Let's take a look at how this works. I'll start by selecting the valve in one of the pipe runs here, which is a pipe accessory. In the Properties palette, you can see that it's a pipe accessory. I'll click Edit Family to open the family in the Family Editor. When you're working in a family, one of the first things you do is select the correct template that you want to use to create the family. And when you do that, the category will be selected. But sometimes you may need to modify this. On the Create ribbon in the Properties panel, you can click Family Category and Parameters to open the Family Category and Parameters dialog. As you can see here, Pipe Accessories is the specified category. We saw that in the project. So once again, when you create a family, you may need to modify this, especially if you start out using one of the generic templates. The other thing you want to pay attention to is the part type. You can choose the part type here in the Family Category and Parameters dialog. The part type is one of the parameters here in the bottom section. Or you can click Cancel to close this dialog and you can see the part type in the Properties palette. When I expand this drop-down, you can see several options. These options will be different depending on what the category is. So for example, pipe accessories will have many more part type options than, say, mechanical equipment and plumbing fixtures. Each of these options has a different behavior. For example, when valve breaks into is selected, then the pipe accessory will break the pipe into two separate pipe segments when that pipe accessory is placed in line with the pipe. If valve normal is selected, the pipe accessory will attach to the end of the pipe. And so that's obviously a big difference in the behavior of how the pipe accessory works. And as you can see here, there are several other options. If you want a detailed list of all the categories and all the part types for each category and some of their default behaviors, you can look this up in Revit Help. I'll switch back to the project, and then I will select one of the fire dampers in the duct, and then click Edit Family. As you can see here, this is a duct accessory, and the part type is set to damper. When I expand the part type drop-down, you can see that there are fewer options than we had for the pipe accessories: attaches to, breaks into, and damper. So this is a fire damper, and so we want this to be set to damper. And once again, these options will greatly affect the behavior. And to see this, I'm going to change this to, first off, let's switch back, and you can see the behavior with damper. I'll select one of the existing ones and click Create Similar, and then I can click in, when I hover over a duct, you can see that it finds the center line, and I can click and place it in line. And now this damper has split the duct into two separate duct segments, and it's placed the damper right in the center. If I switch back to the fire damper family and change the part type to attaches to, and then load it into the project, we'll overwrite the existing version, and then we will place another one. And now, right off the bat, you can see that as I hover over a duct, it's behaving completely different. And I'm trying to find that center line, and I'll click, And when I do, you can see that it's definitely not what I want to happen. And we'll take a closer look here, and you can see that it actually just placed it on the side. So instead of in line, it just attached it to the side there, and that's obviously not what we want in this situation. So in summary, I'll switch back to the family here. The category and the part type is critical, and so you want to get those right from the beginning. In this video, we will cover differentiating between hosted and non-hosted families and recognizing family hosting types. Using hosted or non-hosted families is a classic Revit debate. Some people have strong convictions one way or the other. To begin, let's look at how these are created. Click File, and then select New Family. When you create a new family, you start by selecting the appropriate template. When I scroll down to the generic model templates, you can see several options: ceiling-based, face-based, floor-based, line-based, pattern-based, roof-based, wall-based, so on and so forth. Now, all these different hosting types are not available for every single category, but you can select one of these. Say you want to start with a face-based and then change the category to air terminal or mechanical equipment or whatever you are creating. And face-based, when creating MEP elements, face-based is the way you need to go. And the reason why is because if you create an air terminal using the ceiling-based template, then the ceiling must be in the host model. In other words, you can't have a linked model with a ceiling and then place a ceiling-hosted air terminal. But you can create a face-based air terminal and then place it on a ceiling in a linked Revit model. So, right off the bat, you need to be aware of that functionality. I'll click Cancel, and then we'll take a look at some of the components in this model. When I select an air terminal, you can see a placement panel in the contextual ribbon. And as you can see, face is selected, and so that's an easy way to tell that this is a face-based air terminal. If face and work plane, it could be work plane too, and that would mean that this is a face-based family as long as both of these options were available. Pick New is also available so that you can pick a new work plane, and so that also indicates that this is a face-based family. I'll click Edit Family to open the air terminal, and you can see that there is an extrusion present in the family along with the air terminal. And so this extrusion is indicative of a face-based family. Real quick, I'll create a new family using the ceiling-based template, generic model ceiling-based, and you can see that there is a component, and when I select it, you can see that it's indicated as a ceiling. I'll close that. So face-based, you're going to see an extrusion, whereas one of the other floor-based or ceiling-based or wall-based, you'll see that that component is indicated as such. So once again, if we wanted to adjust this air terminal, we would need to pick a new host, especially if we wanted to move it outside of its existing host, which is the linked architectural model. There can be other components that are hosted, such as plumbing fixtures and even some mechanical equipment you may want to create as hosted. And once again, that's kind of a debate on which one is better, but it kind of depends on what are your needs, what are your workflows, and what's going to work best. One thing that you need to pay attention to with hosted components is if it loses its host. And we'll take a look at that. So let's go to the Manage ribbon, and then in the Manage Project panel, click Manage Links, and select the linked architectural model and select Remove. And then click OK. When we do, we are going to get a warning. There are several warnings actually, and it says Coordination Monitor Alert, a hosting element no longer exists in the link. So we'll click OK and then click OK. Now our hosted components are still there, but if you select one of the air terminals, you can see an icon that indicates that this is an orphaned component, and then you can pick a new host. Once again, that's still available, but it is now an orphaned component. To see all of these, you can switch to the Collaborate ribbon, and then in the Coordinate panel, click Reconcile Hosting. And when you open this panel, you can see all of the orphaned elements. So in this case, I have 41 air terminals that are hosted components that are now orphaned because we removed the linked architectural model. So that's one thing that some people don't like to deal with is having components orphaned. But one of the nice things is that they can be hosted right in the ceiling and remain in that ceiling when the ceiling is moved up or down. The only thing, since it is in a linked architectural model, it will not adjust with the ceiling grids, but it will adjust if that ceiling moves up or down. So once again, hosted, non-hosted components, a classic Revit debate, but regardless of where you stand, it's important that you are able to recognize when a component is hosted or non-hosted. In this video, we will cover controlling family geometry visibility and controlling family geometry graphic display. When you are creating families, you can control how they appear in various views of the project. For example, in this floor plan view, the detail level is currently set to medium. When you change this to fine, you can notice that certain components change the way they appear. For example, the valves in the piping and the dampers in the ductwork now appear with actual geometry. When you change the detail level to coarse, there are changes again. Now the valves and dampers display as symbols. Some of the other components also have slight changes. This can be controlled in the family. Let's take a look at how this works. Select a valve, and then on the contextual ribbon, click Edit Family to open that family in the Family Editor. In this valve family, I'll open the reference level floor plan view, and then to help us see what's going on a little better, I will turn off the display of the annotation categories. Now, in this view, we can see the valve geometry as well as the symbolic lines. When I select an extrusion, you can see that there is a Visibility Settings tool on the contextual ribbon. And when you click Visibility Settings, it opens the Family Element Visibility Settings dialog. Here, you can control the view-specific display as well as the detail levels that geometry will display in. So this view will appear in both plan and reflected ceiling plan views, front and back, left and right views, and then it will only display at the fine level of detail. I'll click Cancel, and then I'll select one of the lines that make up the symbol. Once again, I'll click Visibility Settings. Here, you can see that this line will display in the plan and RCP views, front and back, left and right views, but as far as detail levels go, it only appears at the coarse and medium levels of detail. So be aware that when you create lines or forms to create the geometry in your family, you can then control the view-specific display as well as the detail levels that they will appear at. I'll click Cancel, and then I will switch back to the project. In addition to controlling the visibility of family geometry, you can control the graphic display. Let's take a look at an example. I'll select the water source heat pump and then click Edit Family to open the family in the Family Editor. Let's say we want to create a clearance zone on this water source heat pump and have it appear differently. To do that, let's first create the geometry. So I'll switch to the reference level floor plan view, and I'll create a reference plane. Then I'll click Modify. For this example, I'm going to skip adding a dimension and a length parameter, and we'll just simply add the form. I will use the extrusion tool and rectangle. And then I'll go ahead and lock these. And then I'll click Finish Edit Mode. Next, I'll switch to the front elevation view. Let's zoom in here, and I will extend the height of our clearance zone to match the height of the equipment. And then I'll open a 3D view, and we can see that we have a clearance zone now. But the problem is that it's going to cover up our pipe connectors, and it's going to appear just like the equipment itself. And so if we want this to appear differently, we can create a subcategory. So to do that, on the Manage ribbon, in the Settings panel, click Object Styles. And then in the Object Styles dialog, there's a Modify Subcategories area, and I'll click New, and let's name it Clearance Zone. And since we're working with the mechanical equipment family, that is selected here, so I'll click OK. Now we can control the line weight, the line color, the line pattern, and the material for this subcategory. So I'll change the line color to red, and then let's change it to a dashed line. And then we could also create a material. And so if we wanted to continue in this example, we would create a material that would be transparent, and we could use that to help us as well. But for now, we're just going to do the line color and the line pattern and click OK. And now I'll select that geometry, and you'll notice that there is a subcategory parameter in the Properties palette. I will select Clearance Zone, the one we just created, and now you can see that the geometry for that clearance zone appears red and with a dashed line. While we're here, I want to point out a couple more things. There is a visible parameter in the Properties palette, and so we could create a family parameter and assign it the associate the visible parameter here to that. And we'll do that real quick just to see how this works. Create a new parameter called Clearance Zone Visible, and we want to make sure that this is a yes/no parameter, and we'll group it under Visibility, and we'll make it an instance parameter, and I'll click OK, and we'll leave the default setting as selected, and then click OK. And now I can associate it to this clearance zone parameter because it's a yes/no parameter. I'll click OK. And then we'll load it back into the project. And I will overwrite the existing version. And now we can see our clearance zone. And if I select the water source heat pump, I can also control whether or not that clearance zone is visible. So, subcategories and visibility parameters are a great way to also help you control the visibility and graphic display of family geometry. In this video, we will cover differentiating between annotation and model families and controlling labels in tag families. In this project, there have been some tags that have been placed. When placing tags, there are some important things to understand. First off, tags are view-specific elements, so they will only appear in the view in which they are placed. Tags are also made up of labels, and this controls the parameters that the tags will report. So in this case, we can see mechanical equipment tags, duct tags, air terminal tags, and they're all reporting various parameters. If we want to take a closer look, we can select a tag and then edit the family. For this example, we'll select an Air Terminal tag and then click Edit Family to open the tag in the Family Editor. You'll notice that on the Create ribbon, there are tools to add lines and symbols and filled regions, labels and text, and so these are a lot different than the tools that are available when creating model families. And so the Family Editor will change depending on the type of family you are updating. So in this case, we have a tag family, and so those tools are going to be different because tags are view-specific elements and they do not contain model geometry. Now, in the drawing area, I can see that there are two labels with the line separating them. And so for this example, we are going to remove one of the labels and add both parameters to a single label. So we can start by selecting the label and the line, and we will click Delete to delete them. And then I'll select the first label and click Edit Label. This label is reporting the mark value. Now, you can add multiple parameters to a single label, and that's what we're going to do. And in the list of category parameters, I can see the parameters that can be added to the label. If you do not see the parameter that you want to use, you can click Add Parameter and then select the shared parameter that you want to add to the label. It's important to note that only shared parameters can be added to tag labels. I'll click Cancel, and then I'll select Size and add it to the label. And then I'll select Mark and I will remove it from the label. Next, I will find the flow parameter and add it to the label. And then when you have labels there, or in a label, you can add a prefix or a suffix to the parameter. And then you can also control the wrapping and how that's going to work. And so there are a couple ways to handle this. First off, you can choose to add a break, and that will add a break line in between the parameters. So regardless of the size of the text box, there will be a break between the parameters. You can also choose to wrap between parameters only. And when you choose this option, then a parameter will have a single line. And in other words, it will not wrap based on the text box size. It will only wrap between parameters. Whereas when this option is deselected, then if the parameter value exceeds the size of the text box, then it will go ahead and wrap. For this option, I'll select Break, and then I'll enter a sample value of 10. And then for the flow, I'll enter a sample value of 200 CFM so that we can see how this is going to appear in the project. I'll click OK. And then as I mentioned, the size of the label box, or like a text box here, you can adjust the size of that. And once again, we are not wrapping between parameters only, so if a value exceeds the size of this text box, then it would wrap. And so those are important things to pay attention to. With the label selected, there are also parameters in the Properties palette. The wrap between parameters only, you can select that here as well. So if this is selected, now it's not going to wrap if it exceeds the length of the text box. And you can also control the horizontal and vertical alignment. And then when Keep Readable is selected, if the tag was rotated beyond 45 degrees, it would flip. And then the labels have a visible parameter as well. And so if you had multiple labels, you could create multiple types and create family parameters to control the visibility of the labels. When I click Edit Type, you can see the type properties, which are for the graphics and text. And so you can control the color and the line weight, and then even the background. The background's an important one. If it's set to opaque, it'll cover up components behind it. You can choose to show the border, and then the leader border offset. And then under text, you can control the text style parameters. And those are always important to make sure that your tags match your graphic standards. I'll click OK, and then when I deselect it, you can see that there is now a border around it, and I can select that and click Edit Type again, and if I wanted to make that smaller, a little bit closer to the text, I can control that with the parameter. The last parameter I'll touch on here is Rotate with Component. This is important when you're dealing with duct and pipe tags. And so if they're at a different angle and you want that tag to rotate along with it, you will want to make sure this option is selected. When deselected, you can then set it to vertical or horizontal in the project. I'm going to click Load into Project and then overwrite the existing version. And now you can see that the air terminal tags have updated and they have a nice border around them. And I can make additional adjustments here. Now that I've added the border, we'll move them so they're not overlapping the walls. And so once again, it's important that you know which parameters those tags are reporting, and that will help you as you're documenting your project. In this video, we will cover recognizing use cases for symbolic lines and annotations, and adding symbolic lines in model families. When creating families, you can choose for the actual geometry to appear, or you can use symbols. In this view, you can see air terminals along with pipe accessories and duct accessories that are using symbols. For example, the valves in the pipe are showing the symbolic form of the valve when the detail level of the view is set to coarse or medium. When it's set to fine, the actual geometry appears. Now, as far as actually creating those symbols, they were created as symbolic lines. Remember that pipe fittings and accessories and duct fittings and accessories can use the Annotation Scale. And you can see this parameter right here, Use Annotation Scale, is selected, so when the scale of the view changes, they will scale accordingly. And that is a setting that's in Revit. For other components, such as air terminals, you can also choose how these are going to be shown. In this case, the symbols are shown. The symbol for supply air terminal and for return air terminal are shown. Let's take a look at how these are handled. Select the supply air diffuser and then click Edit Family. In the Family Editor, you can see the air terminal geometry. And when you switch to the reference level floor plan view, you can see the symbols and the symbolic lines and the arrows. When you select an arrow, you can see that these were created as detail items. They are actually nested components in the air terminal family. The reason they were created as detail items is so that they will not scale with the view. If they were created as generic annotations, then they could scale along with the view. For this example, detail items were used, and then there are also visibility parameters for these items that can be used to control whether they actually appear or not. For the symbol of the supply air terminal, symbolic lines are used. Once again, these have visibility settings that you can use to choose the detail levels that they are visible in. And then also note that symbolic elements are only visible in views that are parallel to the creation view. So in this case, symbolic lines were created and they are constrained to the geometry. That way they will flex along with the family. As far as creating the symbolic lines, there is a tool on the Annotate ribbon in the Detail panel. So once again, just to summarize, symbolic lines and detail items will not scale with the view, but they are a great way to show the symbolic form of whatever family you are creating. In this case, air terminals, so that you can show the supply, return, or exhaust symbology. I'll switch back to the project and then open the default 3D view. In this view, the detail level is set to medium. and you can see the actual geometry of the air terminals. As far as the ball valves, you can see the symbolic form. When you select a valve and click Edit Family, and then switch to the reference level floor plan view, you can see the actual geometry along with the symbolic lines. We'll turn off the annotation category so that we can see a bit better. And in this case, you could create symbolic lines, but for them to appear in 3D views, you can also use model lines. On the Create ribbon, in the Model panel, there's a Model Line tool. When you select one of the lines and then click Visibility Settings, you can see that it has view-specific display settings and detail level settings. So these are available for model lines. That way, in a 3D view, you can still see the symbolic representation of the valve. Whereas before, in the symbolic lines, they had different family element visibility settings. And so sometimes you may need to use model lines, sometimes detail lines, and then sometimes a nested detail item or generic annotation. So, depending on how you need it to appear in the project will determine which one of those you need to use. In this video, we will cover recognizing the available parameter types and working with the available parameter types. When working in Revit, information is key. In order to add information to a building model, it needs to be added to a parameter. There are 4 different types of parameters that you can create and use in Revit: project parameters, family parameters, shared parameters, and global parameters. Let's take a look at each one. Project parameters are specific to a project file. Hence, they're called project parameters. When you create a project parameter, you can assign it to categories of elements. And then the project parameter can be used in schedules, but it cannot be used in tags. Project parameters are great when you need to add a single parameter to both system families and loadable families. Or if you have several loadable families in a project and you need to add a parameter to them without opening the families, then you can add a project parameter and it will be added to all of those components in the project. For example, if you have several air terminal families in a project and you want to add a parameter for the neck size, you could either open up each family individually and add it as a family parameter, or you can add it as a project parameter and assign it to the air terminals category, and then all of the air terminals in the project will have that parameter. The only downside is that if you use the family in another project, then it won't have that same parameter. Family parameters are specific to a family. So when you are creating a family, you create family parameters, and they can be used to control family geometry and other variables. The downside to family parameters is that they cannot be used in schedules or tags. But when you create a family parameter, you can actually create it as just a family parameter, or you can create it based on a shared parameter, which we'll get to in just a second. And so there is that ability to create parameters in the family editor and have them be scheduled and tagged. But if you just create it as a family parameter, then those parameters will not be able to be used in schedules or tags. But when you're creating a family, you will typically create several parameters in order to control the geometry and then to add the other variables that you'll need in the family. And so not every single one of those needs to be scheduled and tagged. And so family parameters are still extremely useful when you are developing families. Shared parameters are parameter definitions that can be used in multiple families or projects. And the reason is because they are stored in external text files. So then you can map projects or families to the text file and then be able to essentially pull from those parameter definitions. Shared parameters are very flexible in that they can be used in schedules and tags. And as we've seen with project parameters and family parameters, when you create them, they can be based on a shared parameter. And so that's how shared parameters are used. You either create it as a project parameter or a shared parameter, and then just base it on one of the shared parameter definitions. And then when you're creating tags, you can add shared parameters to the labels, and therefore they can be those parameters can be tagged. So shared parameters are very flexible, and it's important to have a good shared parameter file with all the parameters that you will need in your families and projects. Lastly, we have global parameters. Global parameters are different from the other parameter types in that they are independent of element categories. You can create a global parameter and then use it to drive a dimension or other parameter values. Global parameters can also be used to report values. Global parameters can be extremely flexible and useful in your building models. For example, if you have air terminals placed in offices, and each of those air terminals needs to have a specific flow, let's say 250 CFM, then you can create a global parameter and call it office airflow, and then you can associate that to the flow parameter for all of the air terminals. And then the flow value will always be whatever that global parameter is. Or you can create a dimension, say you need to dimension the air terminals to the wall. Then you can associate a global parameter to each of those dimensions, and it will drive those dimensions. So say it changes and you need to update the distance between the wall and say 50 air terminals. If you have a global parameter that's driving all of those dimensions, then it will update all of those when you update the global parameter. Just to summarize, in a sense, global parameters are almost like a way of making the project environment similar to the family editor, and global parameters can be very flexible in the design process. So just to summarize, there are project parameters, family parameters, shared parameters, and global parameters. In this video, we will cover creating parameters with the correct discipline and data type, and recognizing use cases for the available types. When creating parameters, it's critical that they are assigned to the correct discipline and data type. Before we jump into creating parameters, let's take a look at the units. On the Manage ribbon, in the Settings panel, click Project Units. In the Project Units dialog, there's a discipline drop-down at the top. These are the disciplines that are available when creating a parameter. Select HVAC. Here are the available units and their format for the HVAC discipline. These are the available data types that you can select when you create a parameter. When you click the Format button next to Airflow, it opens the Format dialog. Here you can control the units for the project. In other words, this is the airflow units, and you can set those for the entire project. We'll leave it set to cubic feet per minute. You can also control things like rounding and the unit symbol. I'll click OK and then click OK to close this dialog. Next, scroll down in the project browser and expand Schedules Quantities, and then open the Mechanical Equipment schedule. Next, in the Properties palette, click Edit next to Formatting. When you create a schedule, the schedule uses the units of the project, but you can override those if needed. For example, I'll select cooling capacity and then click Field Format. In the Format dialog, you can select Use Project Settings, or if you deselect this option, then you can control the units and the rounding and the unit symbol. So you can specify the units for the project and then override them in the schedules as needed. But pay attention to the fact that you can only use the units that are available, and different data types have different units. And as you use Revit more and more, you will become familiar with what's available. I'll click Cancel to close the dialog, and then click Cancel to close the Schedule Properties dialog, and switch back to the floor plan view. Next, on the Manage ribbon, in the Settings panel, click Project Parameters. In the Project Parameters dialog, click Add. We're now going through the process of creating a new project parameter. For this example, we will call this parameter Operating Weight. Next, in the Discipline dropdown, you can see the options that we saw in the project units. I'll leave it set to Common, and then we'll expand the type of parameter. As you can see, there are several types, and these types affect how the parameter can be used. Just for example, expand the Discipline dropdown again and select HVAC. Now when you expand the Type of Parameter dropdown, you can see that there are several other types. And these types match the types of units that were available when we were looking at the project units. And so once again, this is where you can create parameters and then specify a discipline and type, and it also associates to those units that were available. So it's critical that the discipline and type of parameter is correct. For this example, we will switch the discipline back to Common, and then in the Type of Parameter dropdown, you can see that we could simply select Number, and we could use the operating weight could be a number. The only downside to that is that we wouldn't have the correct units that we may need. So we can expand the Discipline dropdown again and select Structural, and then expand the Type of Parameter dropdown and select Weight. Now we'd be able to select the units that were assigned to the weight data type. So as you can see, it's important which discipline and type of parameter you use. I'll expand the group parameter under dropdown and select General, and then in the categories list, I'll select Mechanical Equipment, and then I'll click OK, and then click OK to close the Project Parameters dialog. Now, when I select a mechanical equipment component, you can see in the Properties palette under the General section that there is an operating weight parameter. And that was a project parameter we created, and it now has the units that are associated with that data type. And once again, if we wanted to see that, we could open up the Project Units dialog and switch to the Structural discipline, and then the weight parameter, we can see that our units are pounds force. I'll click Cancel to close each of these dialogues, and then I'll select an Air terminal and click Edit Family in the contextual ribbon. In the Family Editor, I'll click Family Types to open the Family Types dialog. Here you can see all of the family parameters that have been added to this family. You can click New Parameter to add a new parameter. As you can see, the options are very similar here, with the most critical being the discipline and type of parameter. I will enter next size, and then in the discipline dropdown, I will select HVAC, and then in the type of parameter, I will select duct size. Note that we could also use a common discipline and set the type of parameter to length to be able to control a duct size as well. Next, I'll expand the group parameter under dropdown, and I'll select general again, and then we will leave it set to instance, or I'll select instance and then click OK. And now I have a next size parameter, and the data type is for a duct size. But once again, there are other options. As you can see here, there's a duct radius and a duct diameter, and if we take a look at those, we can see that they are also of the HVAC and the duct size. And if we select something else like diffuser width and take a look at it, you can see that it's common and length. And so there are some overlapping units between data types, but sometimes you have to be in the exact data type in order to get specific units. In this video, we will cover creating formulas using the proper syntax and recognizing situations to use formulas. Using formulas is a great way to create parametric families and can save you time as you're developing your families. For this example, select an air terminal, and then in the contextual ribbon, click Edit Family. In the Family Editor, on the Create ribbon, in the Properties panel, click Family Types. In the Family Types dialog, you can see all of the parameters that have been added for the family. You can see the parameter name, the value, and there's a formula field. There's already some formulas being used for this family. Let's take a look at this first example. For the duct diameter, the formula is 2 times the duct radius. So that's a quick and easy formula that can save you a lot of time. If you didn't have the formula, you'd have to input the duct diameter for each type. And the more parameters that you have to enter, the more room there is for mistakes. And so this formula will save you time and can also increase accuracy because the diameter will always be twice the radius. You can use basic mathematical expressions in formulas, such as addition and subtraction, and multiplication and division. For a complete list of formula syntax, I would recommend checking Autodesk Help. Let's take a look at some other formulas that can be used. For the arrows, the up arrow, right arrow, left arrow, and down arrow, there are checkboxes. And that's because these parameters are yes/no parameters that are controlling the visibility of arrows. If we wanted to, we could create a formula for one arrow based on another. If we do not want the right arrow to be enabled when the up arrow is enabled, we can type not and then up arrow. When we do, then the right arrow is deselected because the up arrow is selected. And when I deselect the up arrow, then the right arrow is selected. So this is essentially a switch. And then for the left arrow, we could enter right arrow. And I got to make sure that I input the cases correctly and all the spacing. Now when we do this, we have a switch, and then also the left arrow is equal to the right arrow. And so this is just some quick formulas that there's not any special syntax. It's just simply setting one parameter equal to another and one parameter not equal to another. And so that's a quick way to create a switch, if you will, or to equal one parameter to another. We can also use more complex formulas and create if statements. I'll scroll down and we'll take a look at the max flow parameter. And we can write an if statement that's based off of the flow. For example, I will enter if and then an open parentheses, and then we can specify a condition. So I'll type flow is greater than 500, and that'll be our condition. So if the flow is greater than 500. Now we need to type a comma and then input the condition if true, or sorry, the value if the condition is true. So if the flow is greater than 600, is 500, then I want the value to be 600. And if it's not, then I want it to be 550. And I will close the parentheses. So just to summarize what we have here, we have the condition if the flow is greater than 500, and then we have the value if that's true, and then the value if it's not true. And then I'll click out of the field, and that inputs the formula, and you can see that the max flow is now 550 CFM because the flow is not greater than 500, it's actually equal to 500. And if I change this to 501, then the max flow will update to 600. Now, one more thing that you'll notice is that Revit input the units for me. So I did not type CFM, Revit input those units for me after I entered the formula. And so units is something that's important to pay attention to when you're creating formulas. And let's take a look at that. If I enter a formula for the min flow, and I'll simply set it equal to the pressure drop and type enter, I get a dialog that says inconsistent units. And which that's obvious because the pressure drop and the minimum flow do not have the same units. And so you have to be aware that you have to take into account the units when you are creating your formulas. And those are controlled by the data types. You can create if statements based off of other units. For example, if I type if in front of that and then pressure drop, and I'm going to put if pressure drop is less than 1, and then I'll type 300 if that's true, and then 200 if it's not, just for sake of example here. And so if the pressure drop is less than 1, then I want it to be 300 CFM, and so in this case it is less than 1. So what I'm trying to show here is that even though they're not the same units, you can still write an if statement based off of a parameter that has other units. So once again, if you want a complete list of the syntax, I would recommend checking Autodesk Help, but formulas are definitely a great way to keep your families parametric and save you time. In this video, we will cover differentiating between system and component families and editing system and component families. In this project, several elements have been placed. It's important that you understand the difference between system and component families. Component families are also referred to as loadable families. They are defined in the family editor and saved as a .rfa family file. They are then loaded into a project. System families are defined within the Revit project. When you select an element, if you see Edit Family in the contextual ribbon, then you know that that component is a loadable family or a component family. If you select a component and that does not appear, then it's most likely a system family. On the MEP side, ductwork, piping, conduit, cable trays, the actual duct, pipe, conduit, and cable tray, those are system families, whereas the fittings and accessories are loadable families. So those are defined right within the project. In other words, when you select a duct or a pipe, you can then click Edit Type, and you can use the type properties to define that family. In other words, you're not going to open it in the family editor. It's controlled right here in the Type Properties dialog. I'll click Cancel, and then I'll select one of the fittings. When I do, you can see that Edit Family appears, indicating that it is a loadable family. Most of the other components that I have here in this project are also loadable components. I'll select an air terminal and then click Edit Family. When I do, the family opens in the Family Editor, and you can see that the tools are much different than in the project. Here you can create geometry, you can create connectors, you can add parameters, and all of that will control how that family behaves in the project. I'll switch back into the project, and now we'll take a look at editing the families, specifically the loadable family components, and taking a look at some of the things you need to be aware of. When I select this Supply Air Terminal and expand the type selector, you can see that there's one type, a 24 by 24 face 12 by 12 connection. I can click Edit Type to open the type properties, and I can modify these type properties, and I can even create new types right here in the family. So even though it's a loadable family component and defined in the family editor, I can still create a new type here in the project. For example, I'll click Duplicate, and then let's create a 24 by 24 face with a 10 by 10 connection, and I'll click OK. Now I'll set the duct width and the duct height to 10 inches, and then I will click OK. Now when I expand the type selector, I have two types. I have the original one and then the new one that I created. I can click Edit Type and I can switch between those types as well. And the difference is simply two of the parameters. And so once again, your type parameters are what's going to control the family type. I'll click OK, and then I will switch back to the family in the family editor. And now when I click Family Types and I expand the type name, you can see that there's only one type. So this is where it can get a little confusing, because we modified the family in the project, but it didn't update the family file. And the reason is when you load a family into a project, you can still modify it inside the Revit project, but it's not going to affect that external family file unless you open it and then you can save it externally as well. So at this point, we really have two different versions of the family. We have what's here in the Revit project, and then we have what we originally opened before we created that new type. But if I close this and then I open it in the family editor and I go back to the family types dialog, you can see that we have two types now. And I can even create a new type, and we'll create one that's a 24 by 24 face, and let's do an 8 by 8 connection. And then click OK. And we'll set the duct width and height to 8 inches. And then click OK. Now I can load it into the project, and I get this dialog. The family already exists dialog is important. You need to be aware of what these controls do. Overwrite the existing version will overwrite the existing version. It'll add in the new type. It'll add in new parameters that you added. Whereas the second option, overwrite the existing version and its parameter values, will do the same thing. It'll load it in. It will add any new types or any new parameters that were added, but then it will also override parameter values that have been modified in the family editor. With that said, it's not going to override every single one. There are some instance parameters that control geometry that it may not override, but you need to be aware that there can be type parameters that can be overridden in the project. For this example, I'll select Overwrite the existing version, and then when I select the family and expand the type selector, you can see that there are now 3 types. So I know we're kind of going in circles here, but the important thing to understand is that you can create new component family types in the project, and they do not affect the external family file unless you open it after those new types have been created. If you want to adjust the geometry or the parameters that are available, you will need to do that here in the family editor. So, just to summarize, the important thing to understand is that system families are defined within the Revit project, whereas loadable families are defined in the family editor.